Look, I hate to admit it, but I'm a cheapskate. But there's certain areas where I do not scrimp. Number one, peanut butter. I like good peanut butter, and everybody knows that Creamy Jif is the greatest peanut butter known to man. Secondly, I don't scrimp on power supplies. When you take a look at a couple of power supplies, there's a reason why one power supply costs around 39 bucks and another one can cost almost $200. The reasons for that has a lot more to do than simply wattage. Granted, this one has a lot more wattage than this one, but this one comes with a lot of other stuff that you need to be aware of when you're buying your own power supply. The first big one is efficiency. Power supplies do not take the voltage and the amps and turn it in perfectly into watts. There's, because of heat and the mechanism of the switching power supply, there's always some waste. Efficiency is measured as a percentage, so a really good power supply, hint hint, is going to have efficiencies north of 90%, where a not so good power supply, hint hint, is going to have efficiencies that can be as low as 50%. And when we're talking about efficiencies that low, literally take the wattage and cut it in half. That's how important these things are. A good power supply is going to boast about their efficiency. I actually have the box for this power supply here in front of me, and these guys love to show you their efficiency. Let's take a look at this. Okay, as we're looking around the bottom here, first is noise. They like to show that they have a nice quiet power supply. That's not too terribly interesting. It's this second chart right here. You'll see that depending on how heavy the load is, that it can be up to around 92% efficiency. This makes a big difference in overall power and gives you a real idea of the kind of wattage that this type of fella can do. So when you're looking for a power supply, always go with the best efficiency you can. You should never settle for less than about 82 to 85% efficiency. Anything below that is going to be a cheap power supply that will not serve you well in the long term. So efficiencies are good, but the other big issue to watch for is what we call rails. When you take a look at a power supply, let me use this little guy for this example. We're taking 120 or 220 volts that's coming from a household current, and we're outputting that primarily into three voltages, 12, 5, and 3.3 volts DC. The process of converting AC 120 or 220 volt power into 3.3, 5, or 12 volt power requires a lot of switching, a lot of transformers, and as a result of that, you can actually run into problems where you may have enough overall wattage, but because of different outputs plugging into different places on the power supply, you can actually have one particular connection not provide enough power. This is particularly important on positive 12 volt power. So to get around that, what they do is they create something called rails. Rails are electrical circuitry that isolate different types of power outputs, and that way one doesn't get sacrificed to the other in order to do the best efficiency possible. To take a look at rails, if we take a look at this guy here, we'll see, now it's a little bit tricky to read on this one, but if you read where it says max combined power, you'll actually see that the 3.3, and these are all positive, 3.3, 5, and 12 volt are all kind of separated. And you can see that the total wattage is treated separately from the minus 12 and the plus 5 volts on the other side. So you can see we've got 236 watts on one side and 13.6 on the other. That is telling us that this particular system is a two-rail system. The most important voltage you can have on a power supply is your positive 12 volts. And on really good systems, you'll see 2, 3, 4 rails on your power supply itself. Now, when you start getting into lofty heights, these kind of beasties here, the rule set almost goes out the window. So what I want to do is, let's go back to this box one more time, and let's look at the rest of this. And you can see, if you take a very close look, you'll see the plus 12 volt, which is the biggest and most important one. You'll see that it actually shows more wattage than the rating itself. It actually goes all the way to 1204 watts. So if we take a look how it separates the rails here, we'll see it has 1, 2, 3, 4 rails. One's 180 watts, one's 1204.8, boy they got that exact. One's 96, the other one's 17.5. So this is a 4-rail system. If you're going to be buying a good power supply, you certainly need to have a power supply that, number one, has the connections you need. Number two, get a good efficiency system. Oh, and by the way, on efficiency, one of the things you have to watch out for is a lot of times a medium quality power supply will sit there and say, we are 88% efficiency. But it quotes that efficiency at room temperature. And I assure you, when this guy's running, nothing in here is at room temperature. The really good power supplies always quote their efficiencies at operating temperature or at wattage. And that's important because that gives you an idea of what the real efficiency is all about inside the power supply itself. The last thing that you really need to be looking out for is rails. Now, if you don't have a 2-rail system, you're probably going to have an issue. In general, when you start to buy things like high-end video cards or internal hard drive storage, stuff like that, they will literally tell you on the box, they'll say, make sure that your positive 12 volt, usually it's the positive 12 volt, has a minimum of 80 amps. That is kind of pretty much an absolute raw minimum. And when you buy a higher end power supply like this guy was doing 100 amps himself. So these issues don't even come into play. Bottom line, when it comes to power supplies, you get what you pay for. Don't go cheap, and your power supply will treat you right.